right? Just a question. What happens if the power goes out?
We're screwed.
Yeah, right? Oh, let me get the other team. Actually, I kind of have this theory about like all of this technology that like we're kind of at like the cultural hit of technology. Like they're not right now within the next decade. No, as in the level of like the raw level of technology we have available in this society. Because like here's my theory, right? What enables the technology? It's division of labor. What do you need for division of labor? Population. What's in decline? The population. So, well, I would say that, you know, number of transistors per unit area of silicon. Yeah, I think it's actually, like, we'll see. Like, maybe it'll take 50 years, not 10. Sorry? Yeah, but what does operation mean? More levels of division of labor and technology, right? Yeah, sure. We need like you know, a self-creating machine because human beings are gradually losing their ability to do anything. So you know, yeah, I don't think we're there. Greetings. How's everybody doing this morning? I really tried to get a chalkboard in here, but apparently the university actually does have this conspiracy to eliminate chalk. I weep for the future of education. Like, you should keep the chalkboards around, like, just for their, like, symbolic content, if for no other reason. But, yeah, anyway. Trying to think. Oh, the makeup lecture. So I'm thinking that we do the makeup lecture basically the way we had planned to do it last week. We'll just do it tomorrow, if that works for, you know, however many people want to wake up on a Saturday morning. Is that cool? Yeah.
Was it 10:30?
Yes. Yeah, it was 10:30. No. It's 10:30. 11:30, I'll run it into lunch. Yeah, it'll be a live stream from my YouTube channel, so that's automatically recorded and uploaded and available. Actually, quite a lot more quickly after a live stream than it is available after, you know, a live recording. Question? It's symbolic of like the process of education. You know, it's like how a telephone is symbolic of communication.
So why not make an icon on a computer?
Because it needs to be real and physical to have the same semantic weight. I'm not going to get into philosophy with you, but it's not that class. But it's like how this is a real piano, and that's different from being a digital piano. Like even a digital piano, it performs the function of being a piano, but it's not the same thing as a real piano, you know? No matter how good it sounds and how much like a real piano it sounds, it's not going to be a real piano. So there you go. Good. So might as well keep on going then. We should try to plow through the rest of this today and get on to topic, the next one. Any questions on material related before we get started? Cool. So, we were talking about strings. strings. We were talking about what a character is, how strings are composed of them, and some of your basic operations on strings. So here are some properties of strings. So strings, similarly to tuples, are immutable. There's no correct concept of assignment to a string once it's been established. An operation like this will result in an error or an exception, right? The same rules apply with respect to tuples to strings in this respect. Furthermore, the concatenation and search operations, which we previously explored with tuples, are also applicable to strings. So, for example, you could have a phrase like that, and that would form a most of a song from the Beatles. It's very interesting how that particular song is like 60% that one line, It's a really good song though, But anyway. Another, that's probably correct too. Yeah. We've already talked about it a bit, but repetition is a thing that you can do over data structures in Python. Essentially, the multiplication operator has been overloaded so that if you multiply an integer against a data structure such as a tuple or a string, what that does is it creates a new one containing x iterations, x, concatenations of that same data structure all lumped up together. This one is one that people usually forget about by the time we get to file I/O, when it really becomes most useful. How many people have done file I/O before? Okay, so some of you will be learning something in this class this year. File I/O is the process of interacting with files stored on your hard drive. So I sometimes call it permanent memory interaction. It's useful when you're working with files to be able to see what the file extension of the file you're working with is. The suffix text, s ends with t, will tell you whether or not the given string ends with another string. The most immediate and obvious use of this is to test to see if a file name has a particular file extension. You can test to see if it's .py, for example. Make sense? Any questions? Yes? Yeah, sure. Anything you want. There you go. So, topic2.pdf, s.ends with .pdf, true, s.ends with .tech, false. Tech, TEX, by the way, is the file extension for the LaTeX document generation system. Has anybody heard of it? So, LaTeX is the standard documentation generation system for scientific papers in the computer sciences. So if any of you have any idea of perhaps at some point going to grad school, writing papers, having those accepted at scientific conferences, you will eventually have to learn how to use LaTeX. Basically you can submit things in Word document format, but all of the rest of the scientists snigger behind your back. Doesn't even know how to use LaTeX. It's an extremely flexible system, and I use it for all the slides. But anyway, so Yeah, all, like any PDF that you see from me is generated with LaTeX, but that's kind of like beside the point. You guys want to see what LaTeX source code looks like? Yeah, this is just the kind of day it's going to be today. I'll show you the algorithms course I'm teaching at the moment. Algorithms is a lot of fun. These are the slides I was working on yesterday. So this is LaTeX. So this is a LaTeX module known as Beamer. It allows you to create frames, which are basically slides. It's great because, like, I find if you're trying to use anything with like PowerPoint or anything, you spend like half your time adjusting font sizes. You know, like this, you just encode it, compile it, and you're done. It's not a WYSIWYG system, though. You guys know what WYSIWYG is and stands for? Yes? What you see is what you get. That's Microsoft products are based on the WYSIWYG model, which is the thing that you are modifying is the thing that will print out the printer. This is not a WYSIWYG model. This is actually closest to like doing HTML or something like that. But once you compile it into a document, you get like, which slide is this? This is the intro slide. Yeah, so this is what that slide looks like when compiled. So, you know, and it's fun and all kinds of stuff. But anyway, that's second year material. Yeah. So anyway, question.
Is it latex or LaTeX?
It's LaTeX, although it is definitely spelt latex. So, you know, I believe it's German. Like it's a German pronunciation of a German word. But question.
What's it written in?
LaTeX. Like LaTeX, it's not a it's not written in a different programming language. It is written in, like, it's like how HTML is written in HTML. You know.
What's it based on?
I have no idea. It's like very old. It's like from the 70s. Every time I've heard it pronounced by anybody who knows what they're talking about, it's been LaTeX. So, actually, LaTeX is a particular sub-variety of tech, which is like the base system that it was built off of. But and then, you know, the PDF compiler is a different thing. Anyway, we're getting off topic. Oh my God. I'm not even going to, anyway. So, does everybody know how to use print by now? Yes, even if you don't, yes. All right. So, the input function. I've said this previously, but the input function is not how you put input into functions for the purposes of your friggin' assignments. All right? Anybody? Basically, if you start lacing your assignment submissions with this particular drug, then what's going to happen is when we go to auto-grade it, the auto-grader is going to pause and wait for input like on every single person's function for the, like, and it takes a million years to get through it all, and we're just going to be clicking enter anyways, because, you know, it's not even, you wouldn't even probably be prompting us with the correct prompt to be able to enter data. So this is not inputting to functions using function arguments is how you input the functions. Okay? Question?
Are you going to ask us in the assignments to use this function?
Not even once in this course. Not even once. It's useful to know how to do it to interact with standard input, you know, but frankly, at least, you know, in the chunk of this program which I have been responsible for over the years, we get into this type of thing in the C programming course when we're using, like, you know, scanf and that sort of thing. But, like, the idea is that by that time you're good enough with the computers that you can, like, be trusted to understand what standard input and output actually are, you know? So this is still intro programming, basically. But yeah, so the input function, if you're not aware of what it does, it will wait for the user it will wait for a user to enter data. It will collect that data, assign it to whatever variable you're assigning the return result of this input function to, and then you can use it however you wish. So, for example, just for the sake of argument, x is equal to input. What is your favorite color? I'm an adult. I don't have one. Printf x concatenate. What a nice color. There you go. Right? So this is actually a highly flexible system. It's like use of standard input and output is like the cornerstone of Unix and Linux-based operating systems. It is possible to pipe. It's called piping. You take the output of one program, you pipe it into the input of another program. This allows you to chain together long sequences of small programs to affect basically anything you want to do in your operating system, and you can script it, but that's all stuff that you're going to learn in a course that's not this course. That would be non-introductory material. So, let's talk about string formatting. You can use the format, dot format, to format numbers and other values as strings. You can also perform explicit string conversion and concatenation to affect the same thing. However, it's useful to learn how to do this because this is essentially the same way that you'll be expected to know how to do it in other more sane languages. Most particularly, other C-based languages, including C. So, essentially, if you leave open and close curly brace inside of a string, and then you format that with a particular piece of information you're trying to insert into the string, it will insert that into the string with particular modifiers and options which can be specified inside the tag. S specifies that you're adding a string, D is an integer, F is a floating point number. The 0.3 in front of it indicates that you're putting this floating point in 2, 3 decimal places. It's possible to, fix the number of characters which are given to this slot as a fixed number of characters, which allows you to print things in columns nicely, which, basically nobody worries about printing things nicely in columns in like terminal anymore, but, it is what it is. But yeah, and if you want multiple format tags inside of the same string, then you simply format multiple arguments into it. This is how printf in C works, and you have to know how to do this to be able to print anything. So, yeah, most people in Python will just perform string conversion and then use the concatenation operator because it's easier to understand. You don't have to memorize format tags, and it is what it is. But this is how more advanced languages do things. Questions? Good. They're actually very powerful format tags. I have this one assignment question which I do in both of my courses that are C programming courses, which is basically take a date and then change its formatting to be a different type of formatting. I had this one student who did this, had a problem with their solution to this problem, and the question has been written very explicitly to use formatting tags to achieve the formatting, right? my instructor's solutions to this problem is like 12 lines of code, right? This person had written literally 150 lines of code to try to achieve the same stuff, right? And it's like, obviously your code doesn't work because it's 150 lines of code. You know, I'm not like, basically I said, listen, I could either spend the next 3 days trying to read your code, or you could just use the formatting tags like the question was intending. But, you know. But yeah, so I guess the moral of the story is use the tools available to you. So here are a couple of nifty little examples of functions operating over strings. We have a frequency count, which counts the number of occurrences of t in S as a ratio, well, as a percentage of the overall string itself. So in this case, it's just s.count t over the length of S multiplied by 100. So if we have like a series of DNA base pairs, indicated by one side or the other, I'm sure, then the frequency would be just this DNA string. We're counting the frequency of t. Incidentally, does anybody know what these are? Call them out if you know what these chemicals are. Yes. So adenine, thymine, guanine, and cytosine. I think, yeah. So anyway, this isn't a biology class, but you know. DNA is cool. If you don't know how DNA works, go look it up on the internet. It's very interesting. We also have this function, which essentially attempts to pluralize things with the correct rules of pluralization according to English grammar. Basically, if the input string ends with an S, then we use W plus ES, otherwise W plus S. This is a strange way to write an if statement. I'm not sure why you would do this, because, especially on this slide, because like this is the inline if statement spread over 2 lines, right? But the idea with the inline if statement is you put the condition in the middle, the true case comes before, and the else case comes after, and you can like just put everything on one line. It's actually, you've got this in a number of languages as well. In other C-based languages, you have what's called a ternary expression, which essentially serves the same purpose. Syntax for a ternary expression is condition, question mark, true, I think it's colon, false. And that's like, that does the same thing, but that's like the C#, C++ version. Have you gotten the impression that I like C better than Python yet?
Just a little bit.
Just a little bit, yeah. So, here's the slide on that. So, it, shouldn't be too difficult to understand. E if true, else F evaluates to E. E if false, else F evaluates to false. Right? For the beginning programmer, I don't necessarily recommend the use of inline if statements or any inline things until you've mastered the basics. In the same way that like multiple assignment kind of, just complicates things without adding anything. This also just kind of complicates things without adding anything, really. You can use it if you like. Like, the only reason I would see to use something like this is if you really, really, really like compact code and you want to like get your code down to the fewest number of lines of code possible. But you know, there is also overdoing it in that sense. You can make your code completely unreadable by doing that. Like in theory, right? In theory, because this is an expression, both E and F can also be more of these, right? So in theory, if you had if you had an elif chain that was like 10 conditions long, you could encode it using these guys as one gigantic expression that takes like 3 lines in your editor, or 4 lines, or however many lines in your editor. Possible, but not recommended. Especially if you intend anybody to read the code. Of course, you know, since an auto grader will be reading the code primarily, it actually doesn't care about that sort of detail. But any questions about that? So, good. So Boolean operators then. Sort of shifting gears slightly. So we know, we've talked about Boolean comparison operators, or sometimes called comparators. We also have logical operations, which, you know, hopefully you guys come to an awareness of quite quickly. They're very simple once you start using them if you've never used them before. If B and C are both expressions evaluating to a Boolean, in order for B and C to come out true, both B and C must separately evaluate to true, right? So this is true only if B and C are true. That's why it's called AND, right? For OR, you want to guess? The OR operator will only come out true if B or C is true, right? So one of these guys is allowed to be false, but if both of these guys are false, then the whole thing is false. Make sense? This is the one that you may not have seen or heard of before. This is known as the exclusive OR operator. How many people have heard of XOR? Okay, quite a few of you. XOR, it's like it comes out true only if the 2 inputs are different. And it comes out false if they are the same. So basically, you can think of it in a couple of ways, right? You could think of it as the OR operator minus the cases where the AND operator would come out true, right? You can also think of it as different going in is true, same going in is false, right? And that's both of the only ways that there are to think about it. You might ask yourself, well, what would an application be of this sort of thing, this XOR operator? In truth, I've never seen it used on Boolean expressions. However, there is such a thing as a bitwise XOR operator, which I see a fair amount because I teach embedded systems in addition to all of the rest of the programming I teach. So in certain applications, you have to be concerned about what the individual 1s and 0s are doing, right? A bitwise operator allows you to perform essentially these logical operations, but on the individual bits composing the numbers, right? So basically, the 1s and the 0s behave as truth values, and, you know, to perform bitwise AND is to go through each pair of bits one by one, evaluating, you know, them according to the rules of AND, and then you produce a new number, right? To take any number and perform exclusive OR with all 1s inverts every bit in that number. And you can like mask the bits that you want to invert, because otherwise that would just be a 1's complement operation. But you can select which bits you want to invert using the XOR operator and, you know, configuration of C. But that's, you know, again, that's a bit more detail than you actually need. So, I'm going to skip both of those things. We can just move on. So, any questions about any of that? Hopefully not. It's like, in case it needs to be said, there's no gray, there's no gray area when it comes to Booleans. They are either true or they are false. Good. So now we know how to compose expressions. We move inevitably on to, recapping some stuff that hopefully you learned during lecture 1, which is particularly statements. So we're going to talk about loops in more detail. We're going to talk about the for loop, which we haven't seen yet, which requires some elementary knowledge of data structures, which we now have. So first, y'all remember those flowcharts? Hopefully. Wasn't that long ago? Y'all remember these ones? You remember how I said that all computer programs are fundamentally decomposable into these 3 expressions? Oh, 2 expressions technically, because this one here is just this one with a pass instead of a statement on that branch, right? These are your basics. These are things that you need to practice. So, you may ask yourself, what do those look like in Python? Ta-da! But of course, we've already seen these quite a few times by now. So, good. So Python uses indentation for grouping nested statements. I've said this a number of times. If you're used to other languages which use curly braces, Python uses the conventions around indentation and curly braces to actually carry the semantic weight rather than relying on the braces. So if you have not indented appropriately, then you'll get a compiler error. It expects the next line to be indented, and if you do not have your statements at the correct level of indentation, your program will not operate as you intend it to. It's important that the correct number of tabs be there. Make sense? Good. So, let's consider an example. Factorial. Factorial is a mathematical operation that's used to count the number of permutations of a, you guys taken like even a very little bit of combinatorics? No? You guys know what permutation means? I'm seeing, give me a thumbs up if you know. Okay, a little bit. Some people know. So, okay. How many different, okay, so consider a pack of cards, right? 52 cards. How many, if you shuffle that pack of cards, how many unique orderings of cards are there in the shuffled deck? 52 factorial. That's what permutation means. A permutation is a specific arrangement of, or some specific ordering of a set of objects, which can be reordered. Make sense? So the number of permutations is the factorial of the number of the things that can be permuted. All right? Sounds good? Anyway, so mathematically speaking, the mathematical definition of the factorial operator is, should n be 0, the number of permutations is 1. For no, like, that's kind of like the base case. You might think, well, if I have no objects, how can I arrange them once? And it's like, well, just go with it. Should n be greater than 0, It's n multiplied by n minus 1 factorial. Question?
You know why like 0 factorial is like 1?
Personally, I think it would have been just as easy to pick 1 as the base case and have it undefined for 0, but I'm not going to argue with the mathematicians about this. I don't particularly understand it, but then, you know, I don't understand how they came up with the concept of, like, you know, differential equations. So, you know, I can't, like, spontaneously produce the Taylor series expansion, so, you know, that is one of my limitations, and I must learn to overcome my limitations, except that you can't overcome all of your limitations. Otherwise, you would be God. So, anyway, so this is a very specific and particular means of formulating a definition. You'll hear this, this term a lot when you go on to, you know, courses like 1DM3 and 2LC3. This is what we call an inductive definition. It's inductive because it operates on the mathematical principle of induction. All right? Inductive definitions lend themselves to recursive solutions. How many people have heard of recursion? Quite a few of you, I'm impressed. How many people could competently assemble a recursive algorithm? You all will by the time I'm finished with you. So, essentially, the thing that makes this an inductive definition is the fact that the definition of factorial is invoked inside of the definition of factorial, right? Now, under ordinary circumstances, in ordinary fields, this would be considered a circular definition. And circular definitions are generally considered bad definitions. However, we have a case here which breaks us out of the cycle, right? It's a circular definition until it winds down to what we call the base case, at which point the circularness of the definition stops, as this guy, this case, does not require the definition of factorial to be evaluated. Does that make sense? So, if we were to write a recursive algorithm for the factorial function, well, we'll have examples of it later on, but essentially, what makes a function or an algorithm recursive is exactly this point right here. Recursive algorithms call themselves, right? Now, this can lead to problems such as infinite recursion. Infinite recursion is what you get when you have a truly circular definition, in that it doesn't stop at a particular point. You either forgot to include the base case or you skipped the base case somehow. At any rate, it's just going off on to infinity. That can happen, but this is being set up just for the purpose of setting up like very basic while loops, so we'll just get back to the slides, I suppose. So, if we wanted to encode the factorial algorithm, this is how we may go about doing it. So, factorial of n, we declare two variables, I and f. While I is less than n, I is equal to I plus 1, f is equal to f times I plus 1. So, again, this is another one of these nasty little instances where I think that multiple assignment only confuses the matter. You might be given the impression from this, or you might think that the first one is performed first, and the second one is performed second. So, you know, is this I here the I before this addition or the I after this addition, right? Turns out that it's the I before the addition, but you could be forgiven for thinking that it was the I after the addition. This is why you shouldn't use multiple assignment. Okay? Just do it normally. Don't be fancy. He's got enough space in the slide for it to do properly. But anyway. You know, very simply, let's whip that guy up. Okay. Activate live coding mode. Thank you. Topic 3. Boink. Boink. So, define factorial, accepts as an argument n. We set I equal to, what do we initialize it to? I think it was 1, wasn't it? Nope, it was 0. 0 and 1. F is equal to 1. While I is less than or equal to, less than n, F times equals F times equals I plus 1, I plus equals 1, return F. Print F fact at 5. Let's see what we get. Python 3 topic 3.i 120. Is that correct? Yes. Good. So there we go. So this is an extremely common way to construct a loop. While it is a very common way of constructing a loop, it is certainly not the only way to construct a loop. We are using two variables here, which are named the counter and the accumulator. Right? Which one's which? Any guesses? You've got your hand on your chin in a very intellectual fashion. Do you know the answer? No? Okay. Yes, sir.
I is the counter, F is the accumulator.
I is the counter, yeah, and F is the accumulator. That is correct. The difference between the two, well, I'll talk about the accumulator first. So, the reason that the accumulator is called the accumulator is because it will gradually accumulate the correct value, the output value, over the course of the execution of the algorithm. F will gradually become the correct answer through this loop's execution. That makes it the accumulator. I, on the other hand, is simply counting from 0 to n minus 1. It's moving at a fixed pace through the natural numbers, right? That makes it a counter. So, of course, the difference between the accumulator is the accumulator does not necessarily move through its phases at a fixed pace like the counter, right? But you can usually tell what the counter is because it's got like a plus equals 1 at the end of the loop. But yeah, questions? This is like the basics, right? Good. So here's an interesting thing though. What happens if we try to call f outside of the function? Right? Name error, f is not defined. Why? It's certainly defined up here. Why is it not defined here? Yes?
It's a local variable?
It's a local variable, and therefore in the global context it is out of scope. So The explanation for this is slightly complicated, and it has to do with the manner in which the computer systems handles the memory that's declared for the function during the function's call. Have you guys heard of the system stack? How many people have heard of the system stack? How many people have logged into Stack Overflow? Or not logged in, but used Stack Overflow. You don't have to answer questions. So the thing that Stack Overflow is referencing, like the error, the Stack Overflow error occurs when your computer runs out of memory for more function calls because the stack has exceeded its limit in terms of size, and it causes a condition called stack overflow. So the computer maintains a segment of memory known as the system call stack. Whenever you call a function, what's called a stack frame is opened up. It's like a little rectangle of memory that's your playground for this function call, right? Your local variables get stored in there, inside the stack frame. When your function terminates, that function, that stack frame is removed from the stack, and whatever was behind it in the stack is now returns to being the thing that you were operating on. But the stack frame is completely deallocated. So any variables which are stored in the stack frame cease to be. Therefore, you may declare variables here, and you may, create them by executing the function, but once the function ends, all local variables are destroyed. All right? Although the PC way of saying it is that they're out of scope and no longer accessible. Any questions about that? Yes?
Is it bad practice to access global variables within the function?
Is it bad practice to access global variables within a function? Well, it's not good practice. I'm not sure I think I would call it chaotic neutral. So, in general, you will probably hear every single professor you have at this institution tell you to use global variables as little as possible and not at all whenever possible. There are various reasons for this, but the biggest one is that it's contrary to the design goals of good software design. Global variables are the crutch of inferior programmers, basically. It's true, though. So the problem with global variables, right? One of the things that, okay, I'm going to try to make this explanation fit in the next minute, so hold on to your butts, everyone, okay? What causes errors? State. Getting into states that you didn't expect. What constitutes state? Variables. The more variables you hold, the more different states you can't test, right? It's impossible to exhaustively test all of the state in a program because to do so often would take longer than the universe is old. This is a problem known as the state explosion problem, right? The more state there is in the program, the more difficult it is to test. What are global variables? They're state. They're worse than that. They're state that changes the more you execute a function, right? It's not predictable how the state of global variables depends on the length of time the program has been running rather than the actual execution of the function itself. Therefore, it's very, very difficult to reason about the correctness of programs that contain global variables, especially if they use them a lot. To be able to reason about the correctness of a function, you need to be able to assume as close as possible that what goes in is consistent and what goes out is also consistent. The best property to have in a function is that it does the same thing each time you run it if you run it with the same inputs. That is not the case if it's been bumped up with global variables. So, yeah, so that's why don't use global variables if you can help it. There are cases where you know, it's appropriate, but not nearly as many as most people think.